Welcome, ladies and gentlemen. Today we're going to talk about adding and subtracting rational expressions with like denominators. So you're going to need your notes, a pen and a pencil, and a calculator, please. So our learning objective for today is that we're going to learn how to add and subtract rational expressions accurately. Now today we're going to do it with like denominators. All right, just a little review, make sure you have this down. When we're adding and subtracting regular fractions, we have to have common denominators. So in this one, it's really nice. Our denominator is already here. It's common. It's the same. So that's going to be our denominator when we get to our answer. Okay? Now, after we have a common denominator, we're just going to add our numerators together. So we have 9 plus 5, which gives us 14. Once we get here to our fraction, we always have to remember we have to simplify when we can. So in this one, for example, I can take out a 2 out of both of these, and I'm going to be left with 7 over 3. Now, this is going to be my final answer. And we're going to leave them in these improper fractions, okay? All right, moving on. Now, that's how you add and subtract regular fractions. Now we're going to start doing with rational expressions. So same thing, we're going to have like denominators today. So that's really important. All our denominators are going to be the same when we're adding and subtracting. Then what we're going to do is we're simply going to add or subtract our numerators, okay? And when we're adding or subtracting our numerators, we can only add or subtract things that are the same, okay? And once again, we need to make sure our final answer is in simplified form. So make sure you have this down, okay, you guys? We're going to go through 4 examples today. Here is our first example. I have 7 over 4x plus 10 over 4x. So really important, our denominator is the same. So that's going to come over here, and I'm going to have it over 4x. Now I'm just going to add my numerators together. I have 7 and I have 10. They're common. I could add them together, so I'm going to get 17. Now I can't simplify 17 over 4, so then this is going to be my final answer for number 1. Okay, so just 17 over 4x. All right, moving on to example number 2. Here's example number 2. We're going to take 10x over x minus 5 minus 15 over x minus 5. So same thing again, you guys. First thing we're going to check. We have subtraction. And our denominators are the same, so we have x minus 5. Now I have to take 10x minus 15. I can't subtract 10 and 15 because they do not have the same x value. So I'm just going to rewrite it. I'm going to have 10x minus 15 in my numerator. Now we have to get down to making sure that things are simplified. So whenever we get to this point, we have to see if we can factor anything. If we look at our numerator, I can take 5 out of both of these. So when I rewrite this, I'm going to have 5, and I'll be left with 2x minus 3 over x minus 5. Now, I don't have anything I can cancel here, but we always have to make sure we factor to see if there's anything that can be canceled. So this is my final answer in this case because I don't have anything that cancels. All right, already moving on to example number 3. We are cruising today. Here we go. So I have x squared over the quantity x squared minus 3x minus 28 minus 12 minus x over x squared minus 3x minus 28. Now, before we get going anywhere, our denominators are the same. We really need to talk about our numerators on this one. I'm using subtraction, and whenever you do subtraction, you guys, you have to distribute that subtraction to both things. So it's going to go here, and it's going to go here. So it has to go to all the terms in the second fraction, okay, in that numerator. So if I want to rewrite this one, I'm going to have x squared all over my x squared minus 3x minus 28. And now if I'm distributing that negative, it can become a positive problem now. And it's going to be over negative 12 plus x, because both of those signs are going to change. I'm going to get x squared minus 3x minus 28 on the bottom. Now the signs are only changing in our numerator. Now that we have a common denominator, what we're going to do is add our numerators together. So I have an x squared with a negative 12 and an x. So I can't combine anything, but I can write it in standard form. So I'm going to have x squared plus x minus 12 in my numerator, and my denominator is just going to stay the same, so x squared minus 3x minus 28. Now that I have both of those set up, now I have to factor both. Both of them are trinomials, so we're going to be using that AC method. Okay, so our first one, if I do that, I'm going to take A times C, has to add up to B, so I'm going to have 1 times negative 12, which is negative 12, and I need two numbers that add up to a positive 1. So I'm going to use 4 and negative 3. So if I do that, I'm going to rewrite this. I get x squared plus 4x minus 3x minus 12. Now I have to take out that greatest common factor here. So if I do my grouping, put the first two together, put the second two together, this first one I can take out an x, so I'm left with x, and then x plus 4. This second one, because I have that negative out front, I'm going to take out a negative 3, and I'm going to be left with x plus 4. Now we just check, those are the same, so life is good. So I'm going to rewrite the top as x plus 4 and x minus 3. Now I'm going to do the same thing with this bottom one here. I need to rewrite it, so I need to factor it out. So I'm going to take A times C, add up to B. So I'm going to have 1 times negative 28, and I get negative 28. And I have two numbers that add up to equal negative 3. So if I do this, I can take negative 7 and a positive 4. So I'm going to take this and replace it with that negative 3x. So I'm going to get x squared minus 7x plus 4x minus 28. Now I'm going to put my grouping together. So I'm going to group this one. I'm going to group this one. This one I can take out an x. And I'm left with x minus 7. This one I can take out a 4, a positive 4. So I'm left with x minus 7. Now I can rewrite it. So I'm going to have x plus 4 and x minus 7. Now that it's factored out, now we can cancel. Remember, we can only cancel if things are exactly the same. So on the top I have an x plus 4. On the bottom I have an x plus 4. So those can cancel out. I have an x minus 3 and x minus 7. Those are different. So my answer is going to be x minus 3 over x minus 7. And that is going to be my final answer for that one. All right, done with example number 3. On to our last example for the day, ladies and gentlemen. Here it is. We're going to simplify this one. Now we're just adding. Okay, I have an x squared and an x, so I can't combine them together because they're not the same. So I'm going to have x squared plus x over my denominator, which is the same. So I have a 2x squared plus 3x plus 1. Now I need to factor both of these. If we look at the first one in my numerator, you guys, all I can do with my numerator is take out the greatest common factor. Now my greatest common factor on this one, you guys, is just x. So make sure you look for that. It doesn't always have to be a number. Sometimes it's just going to be a variable. So I have x out in front, and then I'm left with x plus 1. Now on the bottom, we're going to do our favorite thing in the entire world. We get to AC method. So we're going to take A times C, and then set up to B. So I have 2 times 1, which is 2. And then I need to have two numbers that add up to 3. So 2 and 1. That 2 and 1 is going to replace that 3x. So we have 2x squared plus 2x plus 1x plus 1. And now I'm going to go through and I'm going to do grouping. First two and last two together. This one I can take out a 2x. So I have 2x and I'm left with x plus 1. This one I can take out a 1, a positive 1, so I'm left with x plus 1. Now, if I rewrite this up top, I'm going to have the ones that's the same. So I'm going to have that x plus 1, and then I'm going to have my leftover, so I'm going to have 2x plus 1. Now that I'm done factoring, now I need to go through and I need to cancel. Only can cancel things that are the same. So I have an x in the numerator, but not in the denominator, so that's going to stay. And then I have x plus 1 and an x plus 1, so those are going to cancel out. So in my numerator, I'm going to have x. In my denominator, I'm going to have that 2x plus 1. This is going to be my final answer. All right, ladies and gentlemen, that is all I have for you today. So I hope you are having the most amazing day, and I can't wait to see you later. Bye.